Alright, welcome back to lesson 15.3. We'll pick up where we left off on question 6. Given that parallelogram LUCK, L-U-C-K, use the figure and the theorems that we just proved, 1, 3, and 4, to find the following. So we just proved that consecutive angles are congruent in 1. In 3, we said that each diagonal of a parallelogram divides that parallelogram into 2 congruent triangles. And in 4, we now know that the opposite sides of parallelograms are congruent and that the opposite angles of a parallelogram are congruent. So we can use that stuff now. Part A says that triangle KCL is congruent to triangle what? So go ahead, pause the video, see if you can figure out the congruency statement. Alright, so hopefully we got that triangle KCL is congruent to triangle ULC. Next, we're going to step it up a notch and add some algebra. So solve for x if the measurement of angle KCU, this one right here, this whole thing, is 10x minus 15. And then angle K, this whole thing right here, is 6x plus 3. Okay, so using our very first thing that we talked about in parallelogram from item 1, we know that consecutive angles of a parallelogram are supplementary. Well, if you look at this, K and angle K and angle KCU are in fact consecutive, therefore they are supplementary. So, for our equation, if we go 6x plus 3 and then plus 10x minus 15, we add those two angles together, that should equal 180 degrees. Definition of being supplementary. And now we can just solve for x. So first we combine like terms. 6x and 10x. We get 16x, and then we also have 3 minus 15, which is negative 12, equals 180 degrees. Then we add 12 to both sides. 16x equals 192. Divide both sides by 16, and we get x equals 12. So all we were doing is solving for x. So x equals 12. Now part C says solve for x and y if KL, there is 2x plus y. LU right here is 7. UC is 14. And KC from here to here is 5y minus 4x. Again, a little floppy. Anyway, so we need to solve for x and y. So first of all, we have x and y in both of these equations. So first we're going to need to get an expression for either one so we can sub it in. Okay, so this is going back to the algebra days. So thinking back to our parallelogram, we proved that opposite sides are congruent. So I know that KL is congruent to CU. So, and we have that KL is 2x plus y, and CU is 14. So now I can solve for y. So y is right here. We just subtract 2x from both sides, and I get this expression for y, which is 14 minus 2x. So now, instead of having this y over here, I can just plug this equation in instead. It's just simple substitution. Okay? And then we can say, because we also know that LU is congruent to KC, and LU is 7. KC is 5y minus 4x. But instead of putting this y over here, we can now put 14 minus 2x. So we get 5 times 14 minus 2x minus 4x. And now we only have one variable, and we can solve for x. So first we distribute, and we get that 7 equals 70 minus 10x minus 4x. Then we combine like terms. Ooh, Christmas colors. And we get that 7 equals 70 minus 14x. Subtract 70 from both sides. I'm going to bring it up over here. And we get negative 63 is equal to negative 14x. Divide both sides by negative 14. A negative divided by a negative is a positive. And we get 4.5 is equal to x. So now that we've solved for one variable, we can go back to our other equation that we used previously, plug x in, and then solve for y. I'm going to do that over here. Take this same equation, 2x plus y equals 14. But now I have what x is, so I have 2 times 4.5 plus y equals 14. 2 times 4.5 is 9. Subtract 9 from both sides, and y equals 5. Ta-da! Alright, next we've got another theorem. The diagonals of a parallelogram bisect each other. Part 7. A. Rewrite the above theorem in if-then form. So go ahead, pause the video, see if you can write it in if-then form. So in if-then form we have if a quadrilateral is a parallelogram, then the diagonals bisect each other. Alright, part B. Draw a figure for the theorem, including the diagonals. Label the vertices and the point of intersection for the diagonal. Identify the information that is given and what is to be proved. So we're going to do another proof. And we're just going to draw a nice parallelogram right here. So I'm going to do that as well. So I've got this parallelogram. And then I'm going to say that we've got vertices A, B, C, and D. And I'm going to draw some diagonals. That's pretty good. And this is going to be point M. So our given is the parallelogram itself. Parallelogram A, B, C, D, and all that comes with it being a parallelogram. And we're trying to prove that AC bisects DB. What does bisect mean? Now, part C, write a 2-column proof for the theorem. Okay, so I went ahead and started my 2-column proof. If you need to pause the video, you can do so to create your little table. So the first one is always going to be the given. We have parallelogram A, B, C, D. The reason is given. Now, since we know it is a parallelogram, we automatically know that the opposite sides are parallel because of the definition of a parallelogram. So AB is parallel to DC, and AD is parallel to segment BC. This is the definition of a parallelogram. Now, just like before, we've got multiple transversals going through parallel lines, so we've got lots of alternate interior angles that are congruent. So I know that this angle ABD right here is going to be congruent to angle BDC, along with angle BAC being congruent to angle ACD. So we can write that down here. Got angle ABD is congruent to angle BDC, and angle BAC is congruent to angle ACD, because when you have two parallel lines cut by a transversal, the alternate interior angles are congruent. Now we also know by the definition of a parallelogram that the opposite sides are congruent. So I've got segment AB is congruent to segment DC because the opposite sides of a parallelogram are congruent. So segment AB is congruent to segment DC by the definition of a parallelogram again. So now, if we're looking at our image, I've got two triangles right here and right here that are congruent again by angle side angle. So I've got triangle DCM is congruent to triangle BAM, by angle side angle. And we're trying to prove that AC bisects DB. Well, we now know all of the corresponding parts of the congruent triangles are congruent. So we know that DM is congruent to MB and AM is congruent to MC. See if I can fit this. CPCTC. And now we know that by the definition of bisector, which means cut in half, that AC does in fact bisect DB because these two halves are congruent. So we know that AC bisects DB by the definition of bisect. Alright, so now we're going to move along onto check your understanding. So go ahead and pause the video right now, and I want you to try and work through number 8, 9, and 10 to check your understanding of what we've been going through. So hopefully you paused the video, and we're going to take a look at these real quick. Number 8 says, why are trapezoids and kites not parallelograms? Well, parallelograms have two pairs of parallel sides. Trapezoids only have one, kites have none. So therefore, the simple answer is they don't have two pairs of parallel lines. Number 9, the measure of one angle of a parallelogram is 68 degrees. What are the measures of the other three angles of a parallelogram? So if we're quickly going to sketch out a parallelogram, doesn't matter which one's 68, so let's say this is 68 degrees. We know that opposite angles are 68, and we know that consecutive angles are supplementary. Therefore, this would be 112 degrees, and then this is also 112 degrees. Then if we use the same parallelogram, one side is 12 inches, the other side is 18. Opposite sides are congruent, so this has to be 12 inches, and this has to be 18 inches. That's it for this lesson. I hope you enjoyed it, and have a good rest of your day.